Hi there, in this video I'm going to do a past exam question on differentiation. So let's take a look at this question. So question number 3, the curve C has equation x equals 2 sine y, and in part A we need to show that the point P having coordinates root 2 pi over 4 lies on C. So let's get back to the paper and pen. So in order to show whether this point lies on this equation, let me put either the x or the y value into this equation in order to see whether we'll get the other value. So for example, I'm going to put the y value, which is pi over 4, into this equation, and let's see whether we're going to get the x value corresponding to root 2. Or you can put the x coordinate, which is root 2, into this equation to see whether you're going to get the corresponding y value, which is pi over 4. So what I'm going to do is I'm going to put the y coordinate, which is pi over 4, to see whether we'll get the x coordinate, which corresponds to root 2. So let's do that. So let's put y is equal to pi over 4. So let's put that into the given equation. So x will be 2 sine and y is pi over 4. So we're going to have 2 sine pi over 4 is the standard result. Sine pi over 4 is the same as 1 over root 2, or root 2 over 2 when rationalised. And we can then cancel this 2 with this 2 here to give us the x value, which is root 2. So that corresponds to the x coordinate of P given. Since when we put the y value in, which is pi over 4, we had the x coordinate, which is root 2, therefore this point P lies on the given curve. So let me just close by saying, therefore P lies on C. So we have another part to do, a part B. So let's go back to the screenshot. So part B is to show that dy over dx is equal to 1 over root 2 at P. So let's see how this is done. Let's go back to the paper and pen. So over here we have this given equation, x equals 2 sine y. To work out dy over dx, we need to differentiate both sides with respect to x. So let's do that very step. So by differentiating both sides with respect to x, so by this sentence we mean working out d by dx of the left-hand term of this equation, which is x, and we're also differentiating or working out d by dx of the right-hand term of this equation, which is 2 sine y. So let's think about this for a moment. So on the left-hand side, d by dx of x, nice and easy, it's 1. However, we need to use a chain rule in order to differentiate this y term, 2 sine y, with respect to x. So let me go through the derivative of that right hand term. Let's call that star, and let's do star as a side calculation. So as a side calculation, let's work out d by dx of 2 sine y. Now, if you're unaware in terms of how to differentiate a y term with respect to x, I have created a video showing you the method and the process of how this is done, and I'll provide a link to that video in the description below. However, back to the question in hand. Now, to differentiate a y term with respect to x, we need to use the chain rule. So by chain rule, and to differentiate a y term with respect to x, so a y term only with respect to x, what we need to do is we need to differentiate the y term only, which is 2 sine y, with respect to y, and then we multiply that by dy over dx. So we applied the chain rule, this chain rule, in order to differentiate a y term only. So remember the process: differentiate the y term only with respect to y and then multiply by dy over dx. So let's go one more stage. Now when you differentiate sine y with respect to y, you get cos y. So we're going to have 2 cos y times dy over dx. So 2 cos y dy over dx. So 2 cos y dy over dx is the derivative of the right hand term, which we name star. And let's include that in our main calculation. So let me continue over here. So d by dx of x, I want to differentiate x, that being 1. The right hand term we differentiated and we had 2 cos y dy over dx. Now we need to work out dy over dx, so let's rearrange. So when I rearrange for dy over dx, so let me continue over here. So when I rearrange dy over dx, so that is equal to, so let's remind ourselves, so when I rearrange I'm going to have 1 divided by 2 cos y. If I divide both sides by 2 cos y, so I'm going to get 1 over 2 cos y. So this is what we have for dy over dx. Now if we go back to the screenshot, in this case we need to show that dy over dx equals 1 over root 2 at p. So if we go back to the paper and pen, this is what we have for dy over dx. But bearing in mind that the coordinate of p is given in the question as root 2 pi over 4, let's replace the y in this case by pi over 4. So if I put the y value, or the y coordinate, being pi over 4, so let's put that into our dy over dx. So dy over dx will be 1 over 2 cos, y in this case is pi over 4, so pi over 4. And provided that your calculator's in radian mode, cos pi over 4 is a standard result. It's 1 over root 2 or root 2 over 2. So I'm going to have 1 divided by 2 cos pi over 4 root 2 over 2. And in this case I can cancel the 2 with this 2 over here to give us what's required, which is dy over dx, and we need to show that dy over dx is 1 over root 2. So this is what we need to show. So that completes part B of the problem. So let's go back to the screenshot. So we have a part C. Part C reads, find an equation of the normal to C at P. Give your answer in the form y equals mx plus c, where m and c are constants. So let's go back to the paper and pen. So in order to work out the equation of the normal, first we need the gradient of the tangent. Now we worked out the gradient of the tangent at P. So if we think about it, to work out the gradient of the tangent, we have the coordinate of P, which is root 2 pi over 4. And in part B, we worked out dy over dx at that point. And dy over dx at that point is 1 over root 2. Now, dy over dx at that point is same as calculating the gradient of the tangent to the curve at that point, in particular at that point P. So let me just say that. So from part B, the gradient of the tangent at P, so let me name that as M1. So M1 is the gradient of the tangent at P, and M1 we worked out in part B as 1 over root 2. We need to work out the equation of the normal. So to work out the equation of the normal, we need the gradient of the normal. So remember, the tangent and the normal are perpendicular to each other. So if two lines are perpendicular, the product of their gradients equate to -1. So in this case, to work out the gradient of the normal, and I'm going to name my normal gradient M2, we're going to use the condition that the product of their gradients, the tangent and the normal gradient, M1 times M2, equate to -1. So that is the condition, remember, for when two lines are perpendicular. So if I rearrange for M2, M2 then is -1 over M1. And bearing in mind, M1 is the tangent gradient and M1 is 1 over root 2. Now, if I replace M1 by 1 over root 2 here, M2, the gradient of the normal, will be -1 divided by M1 being 1 over root 2. And -1 divided by 1 over root 2 is minus root 2. So that being the gradient of the normal. So we have the gradient of the normal, and the normal passes through the point P. So in the question, P is given, P has coordinates root 2 and pi over 4. So to work out the equation of the normal, it's very straightforward. We're going to use the equation of the line formula. So in this case, let's work out the equation of the normal at the point P. So P, remember from the question, P is given, it has coordinates root 2 and pi over 4. So I'm going to be using this formula, y minus y1, and that is m into x minus x1. So since we're working out the equation of the normal, m is the gradient of the normal, so m is m2, m2 being minus root 2. And x1 and y1 are the coordinates where the normal pass through, and x1 and y1 are the coordinates of P. Coordinates of P in this case are root 2, so let's note that down, root 2 and pi over 4. So therefore, let's replace the data into the formula. Let's see what we'll get for the equation. So in this case, when we replace, we're going to have y minus, so y minus, and y1 corresponds to pi over 4, so pi over 4, that is equal to m, gradient of the normal is minus root 2, into x minus, and x1 is root 2. Now, let's multiply the brackets. So let's get rid of the brackets. So we're going to have y minus pi over 4 on the left hand side. Minus root 2 times x is minus root 2x. And minus root 2 times another minus root 2 is plus 2. And if I therefore take the minus pi over 4 to the right, we're going to have y, and that is minus root 2x plus 2, and moving the minus pi over 4 to the right will give us a plus pi over 4. So that should be the solution for the equation of the normal. That's the solution to part C of the problem. So that ends the video. I hope you enjoyed this video. I hope you found this video helpful. Do plenty of practice related problems. If you did enjoy the video, a like rating is very much appreciated, and I hope to see you again. Thank you.